At the university, we've developed, I guess, with our anechoic chamber in particular, a process where we can rigorously and repeatably analyse units. And what we do is we start by basically tapping into the units and pulling the cables off and injecting our own signals into each of the antennas. And what we're able to do in an anechoic chamber is literally here on a wooden board, we're able to spin the antennas in all directions and measure with a reference antenna the signals that are coming out of here, both power and polarization. From that, we can build up these beautiful 3D colored pictures that show how the antennas radiate in each of the units. That is our stage 1 process, effectively. And what's nice about it is it's a real-world measurement. We capture the absolute performance of the antennas in the casings with the circuit boards and with the plastics and on a surface. The second stage involves basically taking that antenna data and combining it with propagation or ray data, basically multipaths and waves. So they all fly around your house in all directions. They go up your staircases, bounce off the walls and all the rest, go through the windows. We trace all of these paths in a software tool and then combine all these paths with these antenna measurements to work out how the signal couples between your router and your mobile device or your laptop. With that information, we can then use a simulation of the 802.11 standard, the Wi-Fi standard, and actually predict the throughput. Fundamentally, the importance of stages 1 and 2 is I can tell you ultimately what the throughput will be of your performance, which is what you want to know, as opposed to some obscure, detailed electromagnetic property, which you don't really want to know.
Okay, so we're in Farncombe's test house. That's where we perform our empirical performance testing of devices such as the new Super Hub. It's part of an overall service, so we've got multi-stages to that service. We work in conjunction with the University of Bristol, who perform the first 2 stages of that service. When we come to the test house here, we are measuring empirical throughput in a home that we like to feel is a representative home. It's a typical 2-storey, 4-bedroom house, brick built, and can be quite a challenging environment for certain devices. So the new Super Hub was tested here in conjunction with competitor products in a variety of different locations, what we call it easy, medium and hard scenarios. So we like to test in 2 main ways with an access point, and a device like the new Super Hub is an access point. We'd locate it in the lounge of the house and have clients located in the lounge, so that's line of sight, nice and easy scenario. We'd locate a client diagonally opposite in the building. We call that a medium location. That's fairly challenging. It's got a few walls and obstacles to negotiate to get to that location. And finally, the hard location will be diagonally opposite and upstairs. So that's the most challenging location in the building, and some of the competitive products we've looked at don't succeed in connecting to that hard location. So it's quite a challenging environment.